Welcome to the next lecture. In this lecture, we will start our discussion with the second chapter, which is symmetrical components. As we already discussed, for solving of an unbalanced system, single phase approach is not possible. If it is a balanced system, single phase approach is possible. For an unbalanced system, single phase approach is not possible. So, to solve an unbalanced system, the symmetrical components are introduced. So, the symmetrical components we defined or we are going to define just to solve an unbalanced system. And we already know that when the system become unbalanced, especially with respect to LG fault, LL fault, LLG fault, the system become unbalanced and symmetrical components are used to analyze such a type of faults. Suppose if it is a load flow analysis, stability analysis, the system is what? Remain in balanced mode, that is why we can go with the single phase approach. So, again I am saying, for solving of an unbalanced power system or to do the analysis on LG fault, LL fault and LLG fault, the symmetrical components are introduced. Okay. So, before going into symmetrical components, let me write some equations with respect to balanced system. So, coming to balanced system, a balanced system consists of three phasors. It might be voltages or it might be currents. We have a three phasors equal in magnitude and phase displaced by 120 degrees. Okay. Sir, there are two conventions you can follow, either ABC convention or RYB convention. So, throughout our discussion we will follow ABC convention, not RYB. Okay. So, even if the problem is given, you must treat like this. A means R phase, A phase means R phase, okay. B phase means Y phase, C phase means B phase, okay. So, it is up to you, you can follow either RYB convention or ABC convention, okay. But it is simple to write the ABC convention, that is the reason why I am following ABC convention, okay. But A represents R, B represents Y, C represents B. Now, coming back, the balanced system means it consists of three phasors equal in magnitude and phase displaced from each other by 120 degrees. For example, if you want to write voltage relations, how to write a voltage relation here? VA is equal to V at an angle 0 degrees. V at an angle 0 means V. Okay. So, what is VB? Equal in magnitude. Now, magnitude of VA is V. Magnitude of VB also V, but phase displaced by 120 degrees. That means VB lags VA by 120 degrees. So, minus 120 degrees. So, you can also write like this, VB equal to VA at an angle minus 120. VA is what? V at an angle 0 or simply V. Both the way you will get the same answer. That means nothing wrong to say like this, VA at an angle what? Minus 120. It's correct. Clear? Now, what is VC? VC equal to V at an angle plus 120 degrees. How to justify this? VC leads VA by 120 degrees or lags VA by 240 degrees. Lagging by 240, nothing but leading by 120 degrees. Okay. So, you may also write like this, VA at an angle plus 120 degrees. This is equally good. So, what I want to say, VA magnitude, VB magnitude equal to what? VC magnitude, that is equal to simply V. So, in a balanced system, we have three phasors because it is a three phase system. So, equal in magnitude and phase displaced by 120 degrees. Okay. Now, that is about balanced system. Okay. So, instead of writing 120 degrees and minus 120 degrees, so every time we will define a parameter called alpha. I am just defining a parameter alpha. Parameter alpha we are defining. The alpha value is 1 at an angle 120 degrees. 1 at an angle 120 degrees. So, this is in polar form. Okay. In exponential form, we can write magnitude is 1 at an angle e power j 2 pi by 3. Otherwise, simply 120 degrees. 2 pi by 3 means 120 degrees because phi equal to 180 degrees. Okay. So, 2 into 180 by 3, 360 by 3, again we get 120 degrees. Otherwise, you can also write like this. So, complex form. How to write in complex form? Cos 120 plus j sin 120. This is in polar form, this is in what? The complex form. Okay. Now cos 120 is minus 0.5, sin 120 is root 3 by 2, which is 0.866. So I can substitute that, minus 0.5 plus j 0.866. That's about the value of alpha. I am just assuming an alpha is 1 at an angle 120 degrees. So that we can write VA, VB, VC vectors in terms of alpha. Things become very simple. That is the reason why we defined alpha. There is no other reason for that. Okay. So we do all the calculations later in terms of what? Alpha only. Okay. Now alpha equal to, again I am writing sir, 1 at an angle 120 degrees, that is equal to minus 0.5 plus j 0.866. This is the first thing we defined. Now what is alpha square? Alpha square means what? Alpha into alpha. 1 at an angle 120 into 1 at an angle 120. If you two polar numbers get multiplied, magnitudes directly multiplied, but phase angles will be added. What I mean to say is, x at an angle theta you have, theta 1 you have, multiplied with y at an angle theta 2. These are the two polar numbers. I think you know this, but just for getting a clarity I am explaining. X at an angle theta 2 and y at an angle theta 2. X at an angle theta 1, y at an angle theta 2. If we multiply this, we get xy. Magnitudes will directly multiplied and phase angles will be simply added. Theta 1 plus theta 2. Simple numerical relation. You know this already. So alpha square can be written as what? 1 at an angle 120 into 1 at an angle 120. 1 multiplied means 1 only. 120 degrees plus 120 degrees, 240 degrees you can write. So 1 at an angle 240 degrees I can write. Nothing wrong to write 1 at an angle minus 120 degrees. 1 at an angle 240 or 1 at an angle minus 120. Both are same. For example, if this is your reference, in this direction if you go 240 degrees, but in this direction if you go 120 degrees, reverse direction. So minus 120 you can write. If this is minus 240, in this direction plus 120. Okay. If this is in this direction, it is minus 240 means in this direction it is what? Plus 120. Okay. So nothing wrong. 240 can be written as minus 120. Minus 240 can be written as plus 120. Okay. Degrees I am saying. Anyway, so alpha square equal to 1 at an angle minus 120. Now what is this value I can write? Check sir. So we can write cos 120, cos of minus 120 plus j sin of minus 120. Cos of minus 120 will be same as it is, minus 0.5. Sin of minus 120 will be what? Minus sin 120. So what I can write now? Minus j 0.866. Okay. So minus 0.5 minus j 0.866. Clear? Now that is about alpha square value. Now alpha cube. Alpha cube I can write 1 at an angle 360 degrees. Nothing wrong to say 1. Alpha cube is nothing but what? Simply 1. So alpha power 4 can be written as alpha cube into alpha. Alpha cube value is 1 multiplied with alpha, nothing but what? Alpha only. So tell me what is alpha power 5? Alpha cube into alpha square, nothing wrong to say alpha square. So what is alpha power 6? Alpha power 3 into alpha power 3, which can be written as 1. So that means anything power alpha can be written as either 1 or alpha or what? Alpha square. Only 3 terms exist. 1 alpha or alpha square. Anything power alpha can be written as what? 1 alpha and alpha square. Let's take alpha power 737. So what is the value of alpha power 737? Now strictly speaking, alpha power 737 can be written as either 1 or alpha or what? Alpha square. But what is the correct answer? We need to check. So you need to divide this 737 with what? 3. Okay. You might have done this in childhood in maths. Okay. The same thing we are going to do. Let's see quickly. 3 2 ja 6. So what I get now? 137 here. Then 3 4 ja 12. So 13 minus 12 1 and 17 we got. Then 3 5 ja 15. So 17 minus 15 is nothing but what? 2. So finally what is the remainder? The remainder is what? 2. So that's why alpha power 737, nothing wrong to say alpha square. That means alpha power this remainder is the answer. So like that, any problem is given something like this, you can solve. So alpha power the remainder is the answer. Clear? Now, so coming to the next thing, if you want to write 1 plus alpha square, so what is that value? So we are adding 1 with alpha plus alpha square. First of all, what is alpha plus alpha square? If I add these two, what I get? Minus 0.5 minus 0.5 minus 1 plus j.86 minus j.86, that is cancelled. Now finally what I get? So minus 1 we get. Alpha plus alpha square is minus 1. 1 minus 1 is what? 0. Careful, this is very important. 1 plus alpha square is always equal to 0 if alpha is what? 1 at an angle 120 degrees. Next we will see what is 1 by alpha. See, 1 by alpha equal to alpha cube by alpha, nothing wrong to say alpha square. 1 by alpha is nothing but alpha square. Clear? Similarly, what is 1 by alpha square? Alpha cube by alpha square, that is nothing but what? Alpha. Now, what is alpha conjugate? Actually, alpha is 1 at an angle 120. Alpha conjugate means 1 at an angle minus 120. What is 1 at an angle minus 120? Alpha square. So, alpha conjugate is alpha square. Suppose if it is alpha square conjugate, that is what? Alpha. Alpha square conjugate will be alpha. Then, next important thing, what is 1 plus alpha? Simple, 1 plus alpha is what? Minus alpha square. Next, what is alpha plus alpha square? That is minus 1. What is 1 plus alpha square? That is what? Minus alpha. Clear? And the next important thing is, what is 1 minus alpha? 1 minus alpha. So if you write 1 minus alpha, just think about here. 1 minus alpha equal to what? 1 minus this number. Correct or not? So what I get now? Directly 1 minus alpha equal to 1.5 minus j.866. Okay? 1.5 minus j.866. So what I get now? If I write magnitude and phase angle, so we get root 3 at an angle minus 30 degrees. Root 3 at an angle minus 30 degrees. Because the magnitude is what? 1.5 whole square. That means what? 3 by 2 whole square. Okay? Plus root 3 by 2 whole square. If you want, I will write 1.5. I can write what? 3 by 2. Magnitude means what? Real part square plus imaginary part square. 3 by 2 square. Plus 0.866 means what? Root 3 by 2 whole square. Now 3 by 2 whole square means what? 9 by 4 plus root 3 by 2 whole square means what? 3 by 4 root over. Clear? So we can write this is root over 12 by 4. Root over 12 by 4 is nothing but what? Root 3. Clear? Because 4 3s are 12, root 3 we get. So that's what I am saying. Root 3 at an angle minus 30 degrees we can write. That is what? 1 minus alpha value. What is 1 minus alpha square value? 1 minus alpha square means what I get? 1 minus alpha square. So we get 1.5 plus j.866, whose value is root 3 at an angle plus 30 degrees. Root 3 at an angle plus 30 degrees. Next, alpha minus alpha square. What is alpha minus alpha square? Just check. Alpha minus alpha square. Alpha is this. Alpha square is this minus. That means what? 0.5 get cancelled. So 1.732 we get. That means plus j 1.732. That means plus j 1.732 means plus j root 3. Nothing wrong to say root 3 at an angle 90 degrees. Alpha minus alpha square. All these values are very important, sir. Okay, I will tell you the simple way to remember this little later, but anyway, alpha minus alpha square is root 3 at an angle plus 90. Now next, what is alpha minus 1? So 1 minus alpha you multiply with what? Minus 1. Minus 1 multiplication means you are multiplying with 1 at an angle 180 degrees. So root 3 at an angle minus 30 plus 180 degrees will be what? 150 degrees simply. Okay. So root 3 at an angle we get plus 150 degrees. Clear? Now the next one is alpha square minus 1. Alpha square minus 1 means root 3 at an angle minus 150 degrees. Next, alpha square minus alpha. What is alpha square minus alpha? Which is minus j root 3. Nothing wrong to say root 3 at an angle minus 90 degrees. Clear? Now these things are very important. 1 minus alpha is root 3 at an angle minus 30. 1 minus alpha square root 3 at an angle plus 30. Alpha minus alpha square root 3 at an angle plus 90. Alpha minus 1 root 3 at an angle plus 150. Alpha square minus 1 root 3 at an angle minus 150. Alpha square minus alpha minus j root 3 are nothing wrong to say root 3 at an angle minus 90 degrees. So to remember this, there is a simple trick here. For example, this is 1. Now what about this phasor? Lags this phasor by 120 degrees. This is lagging this phasor by 120 degrees having same length. Means magnitude is 1, but what I can write here minus 120 degrees. Correct or not? If that is the case, what about this phasor? Leads this phasor by plus 120 degrees. Leading means what? Plus 120 degrees I can write. Now let's see what I am doing here. I am replacing this with what? Alpha square. 1 at an angle minus 120. Just now we have seen alpha square. So I can say this is alpha square. If that is alpha square, now what is 1 at an angle plus 120? This is nothing but alpha only. Now let's see what is 1 minus alpha. Just check. Now this is what we say minus alpha. Now similarly, what about this? This is minus alpha square. Now what about this? This is minus 1. Okay, we define 1 alpha square alpha. Then alpha square, if you write this side exactly 180 degrees, minus alpha square. Alpha if you write like this, minus alpha. 1 if you write here, minus 1. Simple fundamental. Now have a look, sir. So the angle from here to here is 60, 60, 60, 60, 60, 60. So total we get what? 360 degrees. So here to here 120, here to here 120, here to here 120. But if you write this vector here, or if write this phasor here, this part and this part is what? Equal. That means this 120 degrees equally divided. That's why this is 60 and this is 60. Okay. So having understood this, then next thing, have a look, sir. So what is 1 minus alpha? 1 minus alpha is what? Root 3 at an angle minus 30. Have a look. This is what? 1 I am writing here. Now minus alpha I am just writing as it is here. Now if I add 1 and minus alpha, we get 1 minus alpha. This is 1 minus alpha. Clear? Check what is this angle? 30 degrees. That means 1 minus alpha lags 1 by how many degrees? 30 degrees. That is why minus 30. Lagging means what? Minus angle. Correct or not? So that's why 1 minus alpha lags 1 by 30 degrees. And this length is more. So strictly speaking 73.2% more than this. 1 minus alpha will be, we have already done the magnitude, that is root 3. So that's why I can write this is what? Root 3 at an angle minus 30 degrees. So this picture should be in your mind. So you have to remember only one thing. 1, then alpha square, then what? Alpha. What is 1 minus alpha? Okay, alpha will be here. So you have to split here. 1 minus alpha is in between 1 and what? Minus alpha. That means it lags 1 by what? Minus 30 degrees. And anyway, magnitude for all these terms is what? Root 3. Correct or not? I think you noticed one common thing here. Magnitude is everywhere is what? Check root 3. But the phase angle only very important for us. How to remember the phase angle? You need to have this picture in your mind. Okay? So 1 alpha square and alpha. Correct or not? 1 alpha square alpha. 1 minus alpha means alpha this side minus alpha this side. 1 minus alpha, and in between we have 1 minus alpha. Okay, 1 minus alpha lags 1 by what? 30 degrees. Lags by 30, that's why minus 30 degrees. Okay. Now similarly, what is 1 minus alpha square? we need to add these two. So this is nothing but 1 minus alpha square, that is root 3 at an angle which leads 1 by how many degrees? Leading by 30, that's why we get what? Plus 30 degrees. Magnitude is root 3, common. Okay, clear? The same thing we got, check. Next, alpha minus alpha square. See, this is alpha, correct or not? This is alpha, this is minus alpha square. You have to add these two. Okay. I am just writing this parallel vector here. So this is length from origin is called what? Alpha minus alpha square, whose value is root 3 at an angle. Tell me here, this is 30, correct? And what about this? 60. Otherwise, this is 60 degrees, this is 60, means what? This is 30, because this angle is 60. The resultant vector will split this region into equal parts. I am talking this resultant vector in between, split this region into equal parts, because the magnitude of this is same. That's why it is equally divided this region. This angle 60 means here 30, here 30. Okay, now this is 30 degrees, fine. If this is 30, then what? This is 60. That means total is what? 90 degrees. That's why simply from 1, what is this length? Sorry, what is this angle from this this vector angle from 1? 90 degrees. So that's why. So root 3 at an angle I can write plus 90 degrees. That is what? Alpha minus alpha square. Okay. Now after that, alpha minus 1. Correct or not? Alpha minus 1. Alpha minus 1 is root 3 at an angle plus 150 na? Okay. Have a look how we get. So we are adding minus 1 with what? Alpha. So this is the resultant. So this is alpha minus 1. Exactly opposite to what? 1 minus alpha. Check if you have any doubt. Now tell me, this alpha minus 1 value is what? Root 3 at an angle. This is 120, this is 30 degrees. So root 3 at an angle plus 150 degrees. Then after that, alpha square minus 1. So then what I get? This is alpha square minus 1, whose value is root 3 at an angle minus 150 degrees, because this lags this 1 by 150 degrees. Clear or not? In this direction 150. Okay, means in this direction is what? 210 degrees. So root 3 at an angle minus 150, nothing wrong to say root 3 at an angle plus 210. Clear? Now alpha square minus alpha means we need to add these two vector. So what is this now? Alpha square minus alpha, whose value is root 3 at an angle minus 90 degrees. If you have any doubt, check. Alpha square minus alpha lags 1 by exactly 90 degrees. Okay, so that's how we can frame. Understand, sir? You don't need to write, or you don't need to write all these phasors here. You just remember this: 1 alpha square. If anybody asks what is the value of alpha square minus alpha, okay, immediately once you have this picture now, then this is minus alpha. Okay, alpha square minus alpha here. So alpha square minus alpha leads 1 by 90 degrees. So root 3 at an angle plus 90. That is how you can give the answer. Clear, sir? So that's why you don't need to remember all these terms. Okay. So once you have this picture in your mind, 1, then alpha, then what? Alpha square. Then the answering of these things become very, very, very simple. Now we will see voltage relations first, then we will see current relations using this alpha parameter. Okay. Now what is VA? V at an angle 0 degrees, that is V. What is VB? Lags the VA by 120 degrees. So V at an angle minus 120 degrees. So what I can write now? V multiplied with 1 at an angle minus 120. Correct or not? V multiplied with 1 at an angle minus 120. So what I get now again? V at an angle minus 120 only. But what is 1 at an angle minus 120? Alpha square. Correct or not? So that's why I am directly writing alpha square times V. Now what is VC? V at an angle plus 120 degrees. So we can write alpha times the V, because We can write V into 180 angle plus 120. 180 angle plus 120 is what? Alpha. Simply alpha times the V. Now tell me, what is VA plus VB plus VC? That is equal to 0. Why? If you have any doubt, check sir. VA plus VB plus VC. Na? VA is what? V. VB is what? Alpha square V. VC is what? Alpha V. Correct or not? You take V common, what I get? 1 plus alpha square plus alpha. What is 1 plus alpha square plus alpha or 1 plus alpha square? That is 0. So finally V into what? 0, which is equal to 0. That's why directly written VA plus VB plus VC is equal to 0. Just similar to the voltage relations, we will write the current relations of a balanced system. Again I am saying these things are valid for what? Balanced system. Okay. Now what is IA? IA at an angle 0 degrees. I am assuming IA phasor is our reference. Okay, IA at an angle 0, nothing wrong. I. What is IB? I at an angle minus 120 degrees. Correct or not? So I can write alpha square I. So what is IC? I at an angle plus 120 degrees. That is what? Alpha I. So again if you write IA plus IB plus IC equal to what? 0. In a balanced system, sum of the voltages A phase, B phase and C phase voltages if you add equal to 0. Sum of the A phase, B phase and C phase currents equal to what? 0. Now these things are valid for balanced system. But if the system become unbalanced, now these things are what? Not valid. That is why single phase approach is not possible. Again I am saying sir, if it is a balanced system, we can go with what? Single phase approach. If I calculated VA and IA, that's enough. We can define what is VB and VC. VB is alpha square VA, because V is nothing but VA, correct or not? So VB is alpha square VA, nothing wrong. VC is alpha times the VA. This is valid for balanced system. Now IA is what? Simply I. IB is what? Alpha square IA. IC is what? Alpha IA. That means if you found IA, that means one phase information. Remaining two phase informations we can write using simple alpha parameter. But these things are really valid for balanced system. But if the system become unbalanced, that means the system become unsymmetric, then these relations are not valid. Clear sir? That's why for analysis of an unbalanced system, we defined the symmetrical components. Now coming to three-phase unbalanced system, as we already discussed, if system become unbalanced, the only way to solve the power system is using symmetrical components. That means the symmetrical components are used to solve an unbalanced three-phase system. If the system is balanced, then single phase approach is possible. If the system become unbalanced, the only way of solving the power system network is using symmetrical components. Now the symmetrical components are designed by Dr. C.L. Fortes. Actually Dr. C.L. Fortes presented a paper in 34th convention of AEE. AEE means American Institute for Electrical Engineers. So Dr. C.L. Fortes presented a paper in 34th annual convention of AEE, which is held in Atlantic City in June 28, 1918, approximately 100 years back. So the name of the paper is Method of Symmetrical Coordinates Applied to the Solution of Polyphase Networks. According to the theory which is developed by Dr. C.L. Fortescue, which is presented in this paper, till today we are using for solving of our unbalanced power system. That means the solution of unbalanced power system can be easily obtained by symmetrical components. Again I am saying which is developed by Dr. C.L. Fortes, and which is exactly 102 years back, better to say, 2020 today, 1918, 102 years back, he has developed that theory. But till today, we are using the same theory for solution of our unbalanced power system. So if it is a three-phase unbalanced system, then according to Dr. C.L. Fortes theorem, a three-phase unbalanced system is resolved into three balanced system of phasors called symmetrical components of original phasors. I am repeating, a three-phase unbalanced system is resolved into three balanced system of phasors called symmetrical components of original unbalanced phasors. Now let us see here, this is the unbalanced system, consists of how many phasors? Since it is a three-phase system, we have a three phasors A, B, C. You may say they are voltage phasors or current phasors, nothing wrong. For example, let us say VA, VB, VC. But VA, VB, VC are what? Balanced phasors or unbalanced phasors? Unbalanced phasors, something like this. Okay, clear? Tell me, this is what, balanced or unbalanced? Yes, that is what, unbalanced. Okay, something like this we have what? Unbalanced system. Okay, now this is a three-phase unbalanced system having how many phasors? Three phasors. Now resolved into what? Three balanced system, each having again three phasors. Positive sequence is a balanced system, negative sequence is a balanced system, zero sequence is called co-phasal components. Strictly speaking, it is a co-phasal component. Instead of saying balanced, we say it is a co-phasal components. Okay, why zero sequence components is called co-phasal components, we will see little later. Anyway, so we resolve this three-phase unbalanced system into three balanced system of phasors, positive sequence, negative sequence components and what? Zero sequence component. Now how many phasors the positive sequence component having? Just like unbalanced system. Unbalanced system having three phasors. Positive sequence also having what? Three phasors. A1 which represents A phasor, B1 represents B phasor, C1 represents C phasor. Similarly, A2, I am writing negative sequence here. Yeah, negative sequence, the phasor A2 represents what? Unbalanced phasor A. B2 represents what? Unbalanced phasor B. C2 represents unbalanced phasor C. Similarly, A0 represents unbalanced phasor A, B0 represents unbalanced phasor B, C0 represents unbalanced phasor C. The idea is very simple. This is an unbalanced phasors is written sum of balanced phasors. That's what the symmetrical components is saying. The symmetrical components is saying an unbalanced phasor can be written in terms of what? Balanced phasors. Okay. Now A is an unbalanced phasor, that can be written as A1 which is taken from what? Balanced system, plus A2 that is also taken from balanced system, A0 also taken from balanced system. Now what about phasor B can be written B1 plus B2 plus what? B0. C1 plus C2 plus what? C0. Clear? So what the point here is, if I want to solve a three-phase unbalanced system directly, that is not an easy. Why? Because network become unbalanced. VA plus VB plus VC is not equal to 0. If it is not equal to 0, there is a coupling between A phase to B phase to what? C phase. It's not a simple thing to solve. Even if you are solving separately A phase, B phase, C phase, that is also not an easy task here. Why? There exists a coupling between A to B, B to C, C to A. So that is why in a simple way to solve an unbalanced system is using symmetrical components. How we are solving? I am saying positive sequence is a balanced system. If it is a balanced system, you don't need to calculate the three phasor information. If I calculate A1 information, I can write B1 in terms of A1, C1 also in terms of A1. How to write that we will see little later. Okay, but just accept this statement. We are only calculating A1 phasor here. B1 and C1 we can write in terms of A1. Similarly, this is also a balanced system. We are just calculating A2. B2 and C2 can be calculated in terms of A2. B0 and C0 we can calculate in terms of what? A0. That means we are only calculating A0. We are solving for what? A1, A2 and A0. Then B1, C1 we can write in terms of A1. B2, C2 we can write in terms of A2. B0, C0 we can write in terms of A0. That means again what you are doing? We are only calculating per phase information. If the symmetry is lost for a original system, but we are doing per phase approach using what? Symmetrical components. Now that's what the beauty of symmetrical components. Actually, if it is an unbalanced system now, the per phase approach is really we introduced again for unbalanced system using what? Symmetrical components. Anyway, you get more clarity little later. We will see first what is positive sequence component and why the name is given positive sequence, and we will see next negative sequence component and why the name is given negative sequence and why it is called zero sequence or co-phasal components we will see clearly. But one thing sir, what is our sequence? ABC sequence, correct or not? Better to say RYB. The sequence is what? RYB. First R phase, later Y phase, later B phase. That's why what I say, R phase is coming first. After 120 degrees, Y phase is coming. That means Y phase lag R phase by 120 degrees. Because Y phase is coming after 120 degree. Clear? And B phase lag Y phase by what? Again 120 degrees. Clear? So RYB sequence is our original sequence. ABC sequence, according to our discussion, we are not following RYB sequence, RYB phasors, we are following ABC phasors. That's why I can say our sequence is ABC sequence. By default, our power system sequence is what? ABC. That is nothing but positive sequence. Suppose if the sequence is reverse, then that is called negative sequence. Okay. So what is the negative sequence means? This is called positive sequence. Negative sequence means ACB. After A, who has to come? B, then C. But what I am saying, after A, if C comes na, that's enough. It is called negative sequence. Look here. This is A, B, C. I say it is a positive sequence or original sequence. Now, this is A, then C, then B. This is called negative sequence. That means opposite to the original sequence. Clear? Only two sequences. Positive and what? Negative sequence. So as we already discussed, a three-phase unbalanced system is resolved into three balanced system of phasors, namely positive sequence components, positive sequence components, number 2 negative sequence component, number 3 zero sequence components. Clear? So zero sequence components also called co-phasal components. Co-phasal components means which don't have any sequence. There may be positive and negative. Zero means what? No sequence. All the phasors are what? In phase. Means there is no sequence. That's why they are called co-phasal. Co-phasal means what? No sequence. That is the meaning. Okay. So a three-phase unbalanced system is resolved into three balanced system of phasors: positive sequence, negative sequence, zero sequence, also called co-phasal components. We will see one by one. First, positive sequence components. So what is positive sequence component? Sir, which consists of three phasors equal in magnitude and phase displaced from each other by 120 degrees and having a phase sequence same as that of original phasors. What is the original phasor phase sequence? ABC. But here also what? The sequence is what? ABC. But how many phasors we have? Three phasors. Equal in magnitude or unequal in magnitude? Equal in magnitude and having the same phase sequence that of original phasors. Means what? Positive sequence components is nothing but what? Original balanced phasors. The original balanced phasors can also say positive sequence components. Nothing wrong. Clear? So we have a positive sequence component something like this. So I am just writing the voltage phasors here: VA1, VA2 and what? Sorry, VA1, VB1 and what? VC1. What is the sequence now? ABC. Correct or not? So we have three phasors and phase displaced from each other by 120 degrees. Correct or not? Clear? So how to write VA1 equal to some V1 at an angle 0 degrees? That 1 indicates positive sequence. Suffix 1 indicates positive sequence. So we can also say this is what? Simply V1. Now VB1. How to write VB1? VB1 lags VA1 by how many degrees? 120 degrees. That's why V1 at an angle minus 120 degrees. 1 at an angle minus 120 means alpha square. Nothing wrong to say alpha square V1. Now VC1. What is VC1? We can write V1 at an angle plus 120 degrees. Correct or not? VC1 leads VA1 by 120. Otherwise VC1 lags VA1 by 240. Minus 240, nothing wrong to say plus 120. So alpha times V1. So that's about the positive sequence component relation. That is what earlier I already said. If I calculate VA1, what is VB1? Alpha square times VA1. What is VC1? Alpha times VA1. Correct or not? This can be written as alpha square times VA1, nothing wrong. Now what I can write this? Alpha times VA1, nothing wrong. If I know VA1, we can write VB1 and VC1. That's why I am saying the per phase approach is possible for positive sequence components. Clear? Now these are voltage relations. Now similarly what I can write for current relations? Quickly I am writing IA1 equal to what? I1 at an angle 0 degrees, nothing but what? I1. What about IB1? We can write alpha square times I1, nothing wrong to say alpha square IA1. What I can write IC1? Alpha times I1, just similar to this. We are replacing V with I, that's it, nothing else. So we can also write alpha times IA1. Clear? So that's what? If I calculate IA1, IB1 and IC1, we can write in terms of what? IA1 using alpha parameter. So that's about the positive sequence component. But one more relation, sir. If you add A1, B1, C1, that means VA1 plus VB1 plus VC1. What I get? V1 plus alpha square V1 plus alpha V1. If I take V1 common, what I get? 0. Correct or not? 1 plus alpha square we get, that is equal to 0. So what I can write here is VA1 plus VB1 plus VC1, that is equal to 0. Similarly, IA1 plus IB1 plus IC1, which is equal to 0. So don't confuse, these relations are very, very important. We are going to use these relations everywhere throughout our fault analysis. That's why be careful, sir. So that's about the positive sequence components. Again I am saying the positive sequence component means which consists of 3 phasors equal in magnitude and phase displaced by 120 degrees and having a same phase sequence that of original phasors. Now coming to negative sequence. So negative sequence means, again, it consists of 3 phasors equal in magnitude, phase displaced by 120 degrees, but having a phase sequence opposite to that of original balanced phasors. What is the original balanced phasors phase sequence? ABC. But here, what is the phase sequence? ACB. That means it consists of 3 phasors equal in magnitude, phase displaced by 120 degrees, and the phase sequence is not ABC, the phase sequence is ACB. Clear? Now I am showing the negative sequence phasors. So I just showing here voltage phasors. Similarly, you can show current phasors. So that suffix 2 indicates negative sequence. VA2, VC2 and what? VB2. Clear? This 120 degrees. Tell me VA2 means what? I can write V2 at an angle 0 degrees. I am assuming VA2 is my reference. Then we can write simply V2. What about VB2? That leads the VA2 by 120 degrees. Leading, not lagging. That's why V2 at an angle plus 120, not minus 120. That means alpha square V2, nothing wrong to say alpha square VA2. Now, what about VC2? VC2 lags the VA2 by 120 degrees. So, we can write V2 at an angle minus 120. So, sorry, this is alpha, not alpha square. Alpha is 1 at an angle 120 na, so alpha, right. So, V2 at an angle minus 120, nothing but alpha square times V2, which is nothing but alpha square times VA2. So, again I am saying, if I know VA2, I can write VB2 is what? Alpha times VA2. VC2 means what? Alpha square times VA2. You don't need to calculate again VB2, VC2 separately. Again I am saying purpose approach is here possible. Now what about VA2 plus VB2 plus VC2? That is equal to 0. Again check. VA2 plus VB2 plus VC2 means you take what? V2 common. We get 1 plus alpha square alpha. 1 plus alpha square. That is equal to 0. So that's why. So sum of A2 plus V2 plus C2, voltage phasors or current phasors equal to 0. Anyway, this is voltage phasors, but what about current phasors, sir? I am directly writing IA2 equal to simply I2 at an angle 0 degrees. You can write I2. IB2 equal to I2 at an angle plus 120 degrees. We can write alpha times I2, nothing wrong to say alpha square times IA2. Now what about IC2? We can write I2 at an angle minus 120 degrees. So alpha square I2, so alpha square IA2. Clear? Now if you add IA2, IB2 and IC2, what I get? I2 plus alpha square I2 plus alpha I2. So 1 plus alpha alpha square, so that is equal to 0. So sum of the currents of negative sequence in a three-phase system is equal to what? 0. Clear? That's about the negative sequence components. Again I am saying consisting of three phasors equal in magnitude, phase displaced by 120 degrees, but having opposite phase sequence that of original phasors. That means the phase sequence here is ACB. Here what? ACB sequence. But what about here in positive sequence? ABC sequence. Here what? ACB sequence. Please careful about this. Next, zero sequence components. See, according to the definition of zero sequence components, it consists of three phasors equal in magnitude. There is no phase displacement, but there is no phase displacement. That means all are in phase. Clear? So that's why no phase sequence here. If you ask me what is the phase sequence, shall I say ABC or ACB here? No phase sequence. No phase sequence. That is the reason why we are calling cophasal components. No phase sequence. So you can say VA naught, VB naught and what? VC naught. No phase sequence. So that's why they are also called cophasal components. Now tell me what is the relation VA naught equal to VB naught equal to what? VC naught. You can write V naught. So VB, if I know VA naught, VB naught is, and VB naught and VC naught is what? Just same as what? VA naught. Okay. So what I can write here, IA naught, IB naught equal to IC naught, that is nothing but I naught. So if I add VA naught, VB naught and what? VC naught, we get 3 times the V naught or 3 times the VA naught. If I add IA naught, IB naught and IC naught, that is what? 3 times the I naught. That means sum of the positive sequence component is 0, sum of the negative sequence components is 0, but sum of the zero sequence component is 3 times the zero sequence value. Clear? So that's about positive, negative and zero sequence components. Now we can write VA is the sum of VA1, VA2 and what? VA0. Clear? So that's what we are saying. An unbalanced phasor can be written sum of what? Balanced phasors. So VA can be written as what? VA1, VA2 and what? VA0. Similarly, VB is what? VB1, VB2 and what? VB0. VC is what? VC1, VC2, VC0. The same thing we can write for what? Current. IA, IA1 plus IA2 plus IA0. IB, IB1 plus IB2 plus IB0. IC, IC1 plus IC2 plus IC0. Clear? So with that we can write the relation between the unbalanced phasors and symmetrical components, and similarly we can write symmetrical components in terms of unbalanced phasors as well. Now we will see the relation between unbalanced phasors in terms of symmetrical components. So we are going to write the relation between unbalanced phasors and what? Symmetrical components. First I am going to write the voltage relations. Similarly we can write current relations. Okay. So I am just taking an example here. So this is what our voltage phasors. By seeing this one can easily recognize whether it is balanced or unbalanced. Unbalanced. Now I am splitting this three phasors using what? Three balanced system of phasors, namely positive sequence components, negative sequence component and what? Zero sequence components. So mathematically VA is equal to what? VA1 plus VA2 plus what? VA0. So I am writing here VA is equal to VA1 plus VA2, otherwise I will write zero sequence first. VA0 plus VA1 plus VA2. Okay, clear? So nothing wrong to write V0 plus V1 plus what? V2. Okay. Now what about VB? We can write VB0 plus VB1 plus what? VB2. Now that's about VB. VB0 plus VB1 plus what? VB2. Clear? So VB0 equal to VA0. We already discussed earlier. VB0 equal to VA0, VC0 equal to what? VA0. So VA0 is nothing but what? V0. Correct or not? So you write like this, VA0, nothing but what? V0 only. Both are same. Don't confuse. VA0 and what? V0 are what? Same. Because we define VA0 equal to VB0 equal to VC0 equal to what? V0. Okay. VA0 plus. What is VB1? Check, sir. VB1 lags the VA1 by 120 degrees. We already written once again from here. VB1 lags the VA1 by 120 degrees. So VB1 is what? Alpha square times VA1. That means VB1 is VA1 at an angle minus 120. So alpha square times VA1. So alpha square times VA1. So what about VB2? VB2 check leads the VA2. Sorry, this is VC2 and this is VB2. Now it is correct because it's a negative sequence. Yeah. So VB2 leads the VA2 by 120 degrees. So that means alpha times VA2 we can write. Otherwise you can also write here V0 plus alpha square V1 plus alpha times V2. Okay. So that's about VB. Now coming to VC. VC can be written as what? Sum of VC0, VC2, VC1. Correct or not? VC0, VC1 and what? VC2. Okay. So what I can write now? VA0, VB0, VC0 are same. So that's why simply VA0 plus what about VC1? Check here. VC1 leads the VA1 by 120 degrees. Correct or not? VC1 leads the VA1 by 120 degrees. So VC1 equal to what? Alpha times the VA1. So alpha times the VA1 plus what about VC2 lags the VA2 by 120 degrees. So alpha square times VA2. Otherwise simply V0 alpha times V1 plus alpha square times what? V2. Clear? Now we can write in matrix form. Clear? So I am just writing in matrix form. Have a look here. So VA, VB, VC on one side, that is equal to, we will fill this matrix later. So we can write here VA0, VA1 and what? VA2. Sir, careful. This matrix is also called what? Is also I can write like this. V0, V1 and what? V2. Both are same. Because VA0 is V0. VA1 is V1. VA2 is what? V2. Okay. Anyway, have a look here now. What is VA, VB, VC? Check. VA equal to what? VA0 plus VA1 plus VA2. That means I can write 1, 1, 1 here. Have a look please. Everybody. VA0 plus VA1 plus what? VA2. We get VA. The same relation we obtained using this matrix form. Now VB is what? 1 times the VA0 alpha square times the VA1 alpha times the VA2. That means 1 alpha square then what? Alpha. Clear? 1 alpha square alpha. So 1 times the VA0 alpha square times the VA1 alpha times the VA2. What about VC? VC0 plus VC1 plus VC2. Okay, fine. But VA0 plus alpha times VA1 alpha square times VA2. So VA0 alpha times VA1 alpha square times VA2. So that's it. Clear? So we written these 3 equations, this and this using matrix form. Again you solve this matrix, we get what? These 3 equations only. Clear? Now let's see. So this is called primary voltage matrix. Hey, don't think it is a transformer, primary, secondary, no. So original unbalanced voltage phasors is called what? Primary voltage matrix. Don't think that it is a transformer, primary, no. It's a primary voltage matrix. It's a primary voltage matrix. In short, we say VP, matrix VP. Clear? Next, what about this matrix called? It is called sequence transformation matrix. Sequence transformation, in short we can say T. Now what about this sequence voltage matrix? So that is simply Vs. Clear, sir? Careful again. What is VP? I am just writing here. VP, matrix VP is nothing but what? VA, VB and what? VC. Then what about matrix Vs? Sequence voltage matrix. You can write simply V0, V1, V2. Nothing wrong to write what? VA1, sorry, VA0, VA1 and what? VA2. Both are same. And what is sequence transformation matrix? T, that is what? 1, 1, 1, 1 alpha square alpha, 1 alpha, alpha square. Clear? Now just have a look here. Simple form we can write like this: VP equal to T times what? Vs. Clear? From this I want Vs. If I want Vs, I can write like this: Vs equal to T inverse of Vp. T inverse of Vp. What is T inverse? I am directly writing, sir. VA0, VA1, VA2. The T inverse can be written as 1 by 3. You can easily remember 1, 1, 1, but 1 alpha, alpha square. Okay? 1 alpha square alpha. Clear? Okay. So 1 alpha, alpha square, 1 alpha square alpha. Then it's not the transpose, we are exchanging these two rows. Clear? Yeah. Multiplied with VA, VB and what? VC. Clear? So VA0, VA1, VA2 can be written as what? 1, 1, 1, 1 alpha, alpha square, 1 alpha square alpha times what? VA, VB, VC and whole divided with what? 3. Clear? So from this we can write 3 equations. What are the 3 equations? These equations are very, very important, sir. You must remember all the time. VA0 is 1 by 3 times VA plus VB plus what? VC. Now what about VA1? 1 by 3 times VA plus alpha times VB plus alpha square times VC. Now what about VA2? 1 by 3 times VA plus alpha square VB plus alpha times VC. Clear, sir? These relations are very, very, very important. That means VA0 we written in terms of what? Unbalanced phasors. In the problem, unbalanced voltage phasors are given. He is asking to calculate what is VA0, VA1 and VA2. Clear? So using these 3 equations we can calculate that. So these are the symmetrical components: VA0, VA1 and what? VA2. VA0, VA1, VA2, they are called symmetrical components. Once I know VA0, I can calculate back VB0 and VC0. Once I know VA1, I can calculate back what is VB1 and VC1. Once I know VA2, I can calculate VB2 and VC2 using simple this relations. The only thing you need to understand here, positive sequence means we have a what? A same sequence that of original phasors. Negative sequence means opposite. Zero sequence means what? All vectors are what? Equal in magnitude and they are not phase displaced by any angle. So that means they are always in phase. So that's about the relation between symmetrical components and what? Unbalanced phasors. Okay. So we have written unbalanced phasors in terms of symmetrical components. Now here we have written symmetrical components in terms of what? Unbalanced phasors. Now this is what? Voltage relations. Now similarly you can write current relations by replacing V with what? I. Now that is the homework for you. You have to do it. Okay. So only thing here is what? You need to replace V with what? I. Nothing else. You need to replace V with what? I. That's enough. Now we will write some conclusions here. The first conclusion is, for a balanced system only positive sequence components will exist. But one more thing here, balanced system means by default it is ABC sequence or ACB sequence? Sir, ABC. If it is mentioned ACB, you have to follow that. If it is not mentioned means by default our system with ABC sequence only. Okay. Now I am writing for a balanced system, otherwise for a balanced ABC sequence system, what the point is, positive sequence component only exist. We will prove this. Positive sequence components only exist. So for a balanced ABC sequence, positive sequence components will exist. How to prove this? So VA, fine. What is VB for a balanced system? Our three-phase system is balanced now. This is VA, this is VB, this is VC. Equal in magnitude and phase displaced by 120 degrees and phase sequence is what? ABC now. So what is VB from here? We can write alpha square VA. What is VC? Alpha times the VA. Correct or not? VB lags VA by 120 degrees. Minus 120, better to say. Minus 120 means alpha square. So VB is alpha square VA. VC is alpha VA. So you substitute here, what I get? 1 by 3 VA. What is VB? Alpha square VA. What is VC? Alpha VA. So what I get? Check. If you take VA common, 1 plus alpha square plus alpha, that is equal to what? 0. Now that's what I am saying. For a balanced ABC sequence, 0 sequence will not exist. What about positive sequence? Check, sir. 1 by 3 VA plus alpha times, what is VB? Alpha square VA plus alpha times, what is VC? Alpha square VC. So alpha square, right? Alpha VB, right? We are written that alpha times VB. VB is alpha square VA. Now alpha square times VC. What is VC? Alpha times VA. So alpha into alpha square, alpha cube 1. Alpha square into alpha, alpha cube 1. So VA plus VA plus VA. 3 VA by 3, that is nothing but what? VA. Clear? Now what about here? 1 by 3 times VA as it is I am writing. Alpha square times VB. Alpha square times, what is VB? Alpha square VA. So alpha square into alpha square is what? Alpha power 4, nothing but what? Alpha. Correct or not? Alpha power 4 can be written as alpha plus alpha times VC. So alpha times, what is VC? VC is alpha times VA. So alpha into alpha, alpha square. Now tell me, VA if you take common, what I get? 1 plus alpha square. So which is equal to what? 0. That means for a balanced system, otherwise for a balanced ABC sequence system. Again I am saying, I don't need to mention ABC sequence. If I say balanced three-phase system means by default it is an ABC sequence. So for a balanced ABC sequence system, 0 sequence components is 0. Negative sequence components is 0, only positive sequence components will exist. So from this, what I can conclude, the balanced three-phase system and positive sequence system are same. A balanced three-phase system is nothing but what? Positive sequence system. That is the second conclusion, sir. Clear? The first conclusion is, for a balanced ABC sequence system, only positive sequence components will exist. Okay. So second conclusion is, balanced three-phase system and positive sequence components are same. Clear? Now coming to third conclusion, for a balanced ACB sequence system, the negative sequence components only exist. Okay? So balanced ACB sequence, what is the meaning, sir? VA, but this is VC and what? VB. So what I can write? VB alpha times VA. What I can write? VC alpha square times what? VA. If you write, this value will be 0, this value also 0, and this value we get what? VA. If you have any doubt, you just check by substituting what? VB and VC in these equations. Clear? So finally the point is clear. For a balanced ACB system, negative sequence components will exist. For a balanced ABC system, positive sequence components will exist. Clear? Now the fourth conclusion is, if it is an unbalanced system, for a unbalanced system, tell me what components will exist. Strictly speaking, for unbalanced system, both positive and negative sequence components will exist, but zero sequence components may or may not exist. Careful, I will prove this. For an unbalanced system now, what I am saying, positive sequence and negative sequence will exist, definitely exist. But careful with the zero sequencer. Zero sequence components may or may not exist. They may exist, may not exist. Don't say that definitely exist. Definitely exist is not a correct statement. May exist, may not exist. Okay? There may be a chance. Okay? So all the times don't think that the zero sequence components will exist here. Okay? For example, let's say if I written VA is 1, VB is -1, VC is 0. Tell me, is it a balanced system or unbalanced system? 100% it is an unbalanced system. Why? VA, VB, VC magnitudes are not same. Phase displacement is not 120 degrees. Directly you can say it is an unbalanced system. Clear? But check. If you use this equation, what is VA naught? VA plus VB plus VC. 1 by 3 VA plus VB plus VC. What I can write? 0. Correct or not? But what about VA1? VA, VB is there, VC 0. That means what? VA is 1, VB is -1. So that means 1 minus alpha by 3 times what? 1. That means 1 minus alpha by 3. That's it. But what about here? 1 minus alpha square by 3. Tell me, positive and negative will exist here. Positive and negative sequence components are not equal to 0, but zero sequence component is 0. That means for an unbalanced system, positive and negative sequence components will definitely exist, but zero sequence components may exist. That means which may be 0, may not be 0. Clear? So that's why you should be very, very careful with zero sequence components. Suppose if it is 2, then what? So VA 1, VB -1, VC is what? 2. So finally we get this value is 2 by 3. Now this value we get something else. 1 minus alpha by 3 plus alpha square, 2 alpha square by 3. Here 1 minus alpha square by 3 plus 2 alpha by 3 we get. Okay? Clear? So that means all the 3 sequence components are now really existing. So that's why careful, sir. It depends on the network, means voltage and current values. The zero sequence components may or what? May not exist, but positive sequence and negative sequence will definitely exist for a unbalanced system. This is a very, very important conclusion, sir. Generally what the people will think here is, if it is an unbalanced system means all the 3 components will exist. No, it's not correct. Positive and negative will definitely exist. Zero sequence may or may not exist. So I am asking a simple question here. What is the frequency of symmetrical components? Again the people will confuse here to give the answer. Okay. Let's say what is the frequency of VA, VB, VC? Even though they are unbalanced, frequency will not change. Frequency is what? 50 Hz. ideally speaking. Okay, system may unbalanced, but the frequency is what? Very close to 50 Hz. It will not become 0 Hz. So even during unbalanced case also, the frequency of VA, VB, VC is what? 50 Hz. Now my question is, what is the frequency of positive? What is the frequency of negative? What is the frequency of 0? The different people will give different answers for here. Positive sequence means, okay, positive plus 50. Negative sequence means negative minus 50. Otherwise, 2 is there, 2 into 50, 100. And 0 is there, it is 0. Or it is blunder here. Strictly speaking, sir, we have written VA in terms of what? VA1, VA2 and VA0. If the frequency of VA is 50, what we done? Mathematically we are separated. Physically you are not separating. Careful. Using symmetrical components, what we done? We done the mathematical separation. Physical separation is not possible. That means we have written VA in terms of what? VA1, VA2, VA0. Physically we are not separated. Mathematically we are separated. Careful about this. So that's why the frequency of positive, negative and 0 sequence is what? 50 Hz. If that is the case, now I am asking a simple question. You might have studied about harmonics in transformers and even in power electronics also. What is the frequency of fundamental? Fundamental frequency is what? 50 Hz. What is the frequency of third harmonic? That is 150 Hz. 3 times the fundamental frequency. Okay. What is the frequency of fifth harmonic? 5 times the F, where F is what? 50 Hz. What is the frequency of seventh harmonic? 7F. And next, 9th, then 9F, 11th, 11F, then 13th, 13F, then 15th, 15F, 17th, 17F. Correct or not? And after that 19th, 17 means 19 next, 19F. Now this is about the harmonic frequencies. This is fundamental. The remaining all are called what? Harmonics. Clear? Now just see, sir, the positive sequence is same as what? The original balanced phasors. That means the positive sequence and fundamental having what? Same relation, strictly speaking. Okay. Next, third harmonic is just similar to what? 0 sequence components. Okay. Clear? See, third harmonic voltage is V in A phase, na? What is the B phase third harmonic voltage? Same V. No difference. Clear? What about the C phase third harmonic voltage? Same. For example, I am just only writing for third harmonic, sir. If this is the fundamental, what is the meaning of third harmonics? In one cycle we get how many third harmonic voltage cycles? 3 cycles. Okay, something like this. That is for what? R phase. After 120 degree Y phase will start, na? So Y phase also if you write, na? See, this is 60, this is 60, 120 degrees. Then Y phase will start after 120 degrees. This is R phase. Y phase will start after 120 degrees. Same thing we get. That means the point is clear. In case of third harmonic, again after 120 degrees, the C phase will start. So just check. In case of third harmonic, A phase, B phase, C phase voltages are always in phase. Okay. Similarly, 0 sequence also, A phase, B phase and C phase voltages are always in phase. So the point is clear here. Sir, third harmonic components having similar nature as what? 0 sequence components. But don't say that third harmonic is nothing but 0 sequence components. No. Why? 0 sequence components frequency is 50 Hz, but third harmonic frequency is 150 Hz. Nature is same. Their magnitudes and other things are equal. No. The nature of third harmonic components, the nature of the what? 0 sequence components are what? Similar. Okay. So that's why I am writing, sir. So fundamental means it is just similar to what? Positive sequence. Third harmonic means just similar to, the nature of the third harmonic is what? Just similar to 0 sequence. Then after that, fifth harmonic means just similar to negative sequence. Seventh harmonic is similar to, again repeat, positive sequence. 9th harmonic is just similar to 0 sequence. 11th harmonic is similar to negative sequence. 13th harmonic is similar to positive sequence. Now 15th harmonic is similar to 0 sequence. Something like that it will proceed. That means fundamental, then 7th harmonic, then 13th harmonic, then 19th harmonic are similar to what? Positive sequence. Remember sir, this is the next conclusion. Okay? And third harmonics, triplet harmonics, 9th harmonics, 15th harmonic, after that 21 similar to 0 sequence. And then 5th harmonic, then 11th harmonic, then 17th harmonic, okay, after that what? 23 similar to negative sequence. Okay, clear sir? So this is very important conclusion. They are just similar, but the vectors, the phasors is not exactly equal. Why? The frequency of fundamental and positive sequence is same 50, but the frequency of 7th harmonic is how much? 350 hertz, but the frequency of positive sequence is what? 50 hertz only. Okay, clear? The nature is same, but they are not exactly equal. Okay, so that's about the last conclusion of our symmetrical components. So with this I am concluding this lecture. Thank you.